Good morning, fourth grade. Today we are going to be talking about triangles and quadrilaterals. So we are actually going to start off with triangles. So I would like you to watch this little video clip here. Just a second.
So today we're going to explore quadrilaterals. But first, let's start out with some polygons. So, if we sort these into polygons and non-polygons, we'll remember that polygons have two major things. One, straight sides, and two, closed figures. So there are two really important features about polygons. One is its sides. So if we take this triangle, for example, there are three different sides there. 1, 2, 3. Also, polygons have angles. So if we look at the triangle again, there's an angle up top, a little bit of a smaller angle down bottom, and then another angle in the corner. This angle is a special angle. Does anyone remember what it's called? That's right, it's a right angle. So it has an L shape in that corner. We have one other key vocabulary word, parallel lines. Parallel lines are directly beside each other. If they were to go on forever and forever, they would never touch. So some lines that are not parallel, you can see here and here. Alright, so now that we've looked at polygons and some of our vocabulary words, let's look at quadrilaterals. So quadrilaterals really only have two major things. One, they're made of straight line segments. So really, they're just polygons. But they're polygons that have four sides. This is the key part for quadrilaterals. So our first quadrilateral is a square. 1, 2, 3, 4 sides, making it a quadrilateral. Then two different sets, right here and right here, of the sides are parallel lines. Also, if we were to take off the sides and put them side by side, they would all be exactly equal. Finally, squares have four angles, and every single angle is a right angle, making that L shape in the corner. Another quadrilateral that you've probably seen before is a rectangle. A rectangle, just like squares, they have four right angles. They also have two sets of parallel lines, right here and right here. But unlike a square, rectangles, if you were to take their sides off, their sides are not all equal to each other. And the next quadrilateral is called a parallelogram. These ones do not have any right angles, none. They do have two sets of parallel sides though. And also, if we were to line up these sides, just like the rectangle, they would not be equal. Then we have a rhombus. Rhombuses, just like parallelograms, do not have any right angles, none. They do, just like parallelograms, squares, and rectangles, have two sets of parallel lines, right here and right here. With all of these sides, if we were to line them up, just like with a square, they would all be the same exact length. And our last quadrilateral for today is called a trapezoid. Now trapezoids can come in many different forms that look kind of different from each other, but they're all still trapezoids. The main thing is that they just have one set of parallel sides. Only one. The other side is not parallel. So let's go ahead and give this a try now. What polygon that is a quadrilateral has four right angles and all the sides are equal? That's right, it's a square. Alright, so what if it has four right angles, but the sides are not all equal? And that would be a rectangle. Okay, so two sets of parallel sides, and the sides are all equal, but they're not all right angles. And that would be a parallelogram. Alright, and what about if there's two sets of parallel sides, and the sides are all equal, but they are not all 90-degree angles? And that would be a rhombus. Alright, last one. There's only one set of parallel sides. The sides are not all equal. So remember, one set of parallel sides. and that would be a trapezoid.
Okay, now that you've seen that short video about quadrilaterals, if you want to take a look at some examples and some more examples, you can find that in your textbook on page 445. So if you're needing to take some notes or look at some further examples, go to page 445. Now the next section we're going to look at is about triangles, and I'm hoping a lot of you remember last year from 3rd grade about triangles. So let's start off with by watching this short little video. Okay, now that you watched that, hopefully you remember some information about triangles. So let's talk about some aspects of triangles that we have to remember. One thing that students always forget is I always say that triangles have, just like you do, a first name, a middle name, and a last name. Now the last name is easy because all triangles have the last name of triangle. But we're going to talk about a triangle's first name. It has 3 different possibilities like you just saw in the video. One of them is the name equilateral. And what equilateral means is, you see the part of equal in there. It means it's just a triangle that has all equal sides. Now this one's probably not perfect, but a lot of times you'll see a little dash like this, and that shows that this side is the same length as this side and the same length as this side. So if all equal sides, the first name would be called an equilateral. Another possibility for sides are what referred to as isosceles. An isosceles triangle has 2 equal sides. And the way that I've always remembered this is I think of an eye. How many eyes do you have? You have 2 eyes, just like an isosceles triangle has 2 equal sides. The other possibility for the first name is a scalene. Now, I've had students throughout the years think of different ways to remember this, but a scalene triangle simply means that this side measures different from this side, which measures different from this side. They all three have different measurements. Students last year talked about, well, are fish scales all the same? I guess I'm not for sure, but if you could think of it like a fingerprint, they'd all be different. So scales, most of us probably don't even weigh the same if you got on a scale. Think of it something like that, but scalene does not equal the same. No equal sides. Okay, so that's the first name, our possibilities: equilateral, isosceles, and scalene. The other possibility that it didn't mention a lot in that little song was the middle name. And while this one talked about the sides, the first name talks about the sides, the middle name talks about the angles on the inside. And we talked about angles on Friday last week. The one that was mentioned was right. A right angle, as we know, makes 90 degrees like this. This is a right angle. And if you have a triangle that has one right angle on the inside, its middle name would be called right. The two other angles we know that we talked about are acute, meaning if you have acute angles on the inside, and obtuse. Now, what's interesting about the middle name, we know that an acute angle is less than 90, and we know an obtuse is greater than 90. So with all of these angles, once you figure out the sides, you could possibly have an equilateral acute, or you could have an equilateral right. You could have a combinations of a lot of these different sides with the angles. So we really do have to look at each triangle separately and analyze first its sides to decide what its first name is, and then its angles to decide what its middle name will be. So let's take a look at a couple here. So let's analyze a couple of these triangles. You can see this triangle here. As it is, we're not for sure if it is what kind of sides. So we either have to have measurements on each side, or if you have these marks showing like this shows that this side is the same size as this and this. So if we know that all three sides are the same, we would call this an equilateral triangle for the first name. Now we have to come up with the middle name. We know the last name's triangle. We'll take a look at the angles. If you have one right angle, we would call it an equilateral right. Do you see a right? Nope. So then we look. I always look to see, do I have an obtuse? Because if there is one obtuse angle, we would call this an equilateral obtuse. There is no obtuse. And if you look at all three angles, this one is acute, this one is acute, and this one is acute. So this particular triangle would be called an equilateral acute triangle. Okay, let's take a look at another one. Again, when you very first look at this, unless you have measurements here, we're not for sure. Now we can clearly see that this side down here is much shorter than this one, so we know it's not going to be equilateral. But let's say this side is different than this side, and it is different than this side. So what would we call it if we don't have any equal sides? That would be called a scalene for the first name. Now let's look at for the middle name. For the angles, I notice that this is acute and this is acute, but what do you notice here? One right angle makes it a scalene right triangle. Take a look at another one here. This one here, two equal sides, we would call that a what? Isosceles. Do I have a right angle there? No. Do I have an obtuse angle there? No. So this would be called an isosceles acute triangle. This one here, let's say that this side was 17 meters, this side was 15 meters, and this side was 16 meters. And that shows their actual measurements of the side. Well, that would tell us again, no equal sides, scalene, and this one angle right here, that is an obtuse triangle. Again, you can look in your book if you need more examples on page 444 and 445.